So these are the safety associations or the safety standards that we're dealing with. ANSI, American National Standard Institute, and RIA is the Robot Industries Association. We roughly deal with the R1506, R15.06, revision 2012. And we don't deal in this class with part 1 because that deals with manufacturers, but we're going to deal with we know that. Hopefully y'all know what a space is, right? Everybody okay with the space? It was previously called the envelope, but this is one of those terms that's going to hang around for years because envelopes were used for so long. But IRA revised that to refer to that as a workspace instead of a work envelope. But it's just like anything else. If a term's been used for years and years and years, in fact, I still use the term work envelope a lot, right? You're okay there. Maximum space, the volume of space encompassing the maximum design movement of all robot parts, including the end effector workpiece and the attachment. So if that robot over there was not in a cage and it was not limited to anything, that would be the maximum space. Y'all understand that? Restricted space, so the restricted space is within the maximum space. Every one of these robots operate within a restricted space. We've got walls up there, right, that's well within the maximum space. So we're not allowing any of these robots to go into their maximum space. Even the big FANUC over there. If we go over and look at the big FANUC, we'd see there's these metal tabs down at the bottom that prevents it from jogging into the wall. If those metal tabs was not there, then I would be operating in the maximum space, which means I could wipe some stuff out, right? You understand that? So these robots over here, these are the maximum space would be, including the gripper, the maximum space that robot could move within if I did not restrict it. So now all these robots are restricted, right? You understand that? Yes or no? Everybody okay? So where's the restricted space? Within the maximum space. Y'all understand? Yes or no? Okay. Now, we don't want the robot to hit the wall when I write a program. Do y'all understand that? Yes or no? That's bad. That's what we call a collision. Just like you don't want your car to run into a telephone pole. All right? So we have what we call operational space. This is the portion of this is the portion of the restricted space where you program the robot. So the operational space is within the restricted space, which is in the maximum space, right? You understand? Everybody okay? And then the safeguard space is the space defined by the parameters of safeguarding devices. So this would be all your safety interlocks that are on your work cell up there. Y'all understand? Everybody understand what we call a 3-positional enabling device? What position must it be in to operate the robot in the teach mode? What? Center. A lot of people miss that. A lot of people said the first position. The first position is what it's in if you don't touch it, right? You understand? The second position, or the center position, is where you put it at so you can jog the robot. The third position is like an e-stop. The robot will stop, right? You understand that? If you grip too hard. Everybody within the work cell is supposed to have, that's working inside the work cell, must have a 3-positional enabling device. So we got emergency stops and safety stops, right? Y'all understand the difference. Control reliable. This is what control reliable says. Control reliable is hardware. Control reliable cannot be software. Because people write software, right? You understand? Control reliable safety circuits shall be designed, constructed, and applied such that any single component failure shall not prevent the stopping action of the robot. Do y'all understand that? So if I was to take that e-stop button apart, you would see there is actually two circuits in there. There's two switches in there. Now they're controlled by the same operator. Those two e-stop buttons go to different circuits. So what it would look like is electrically, if I drew a diagram of it, just the e-stop circuits, but this would be true for all your, where did I insert that page yet? I know I inserted a page. So I'd have one circuit coming up. This would come up, it would go to an e-stop button. Okay, this would come down and go into its own section of the controller. We would come over here, we would have another circuit, completely different circuit. It would come over here and it would have the same another e-stop button, and then it would go into a different circuit. So what we have on our controller is we have two e-stop circuits. And these switches are mechanically connected together. So if something happens to this switch, right, you'll understand, this switch would work. If something happened to this switch would work. If something happened to this circuit would work, right, you'll understand. And that's what we talked about control reliable. So all our safeguards, I could do this same circuit for the safeguards, the e-stops. They're all what we call control reliable circuits. We have two mechanical switches and we have two circuits on the controller. So that means if one circuit fails, hopefully the other one's going to work, right? You understand? And that's what we mean by control reliable. So your safeguard circuits and your e-stop circuits on these robots have to be a control reliable circuit. So when you let go of that teach pendant, the robot's going to stop, even if something's happened, right? Even if a wire on the it got broke within, of course, if a wire got broke on the e-stop, it would stop anyway. So this is control reliable. What else did we have on the test that y'all messed up on? Let's see, hazards. Cause of accidents. Of course, a major cause of accidents in robotics is people slipping off things, right, or falling. We have people that climb up on the robot when they're trying to do something and slip off of it. Probably the most dangerous thing is getting caught between the robot and something in a peach pot. So human factor. Basically, who's responsible? Safety is responsible for everybody, right? But these are the ones that y'all had problems too. Levels of robot safety. So level 1, these are systems intended to detect that an intruder has crossed the parameter boundary of the work cell without regard to the location of the robot. Level 2 systems are designed to detect the presence of an intruder in the region between the work cell boundary and the limit of the work cell's volume. Everybody understand that? Level 3 systems provide intruder detection inside the volume of the robot. All ours have is level 1. So all we can tell on our work cell if you open the door. We can't tell if you're in between the door or the sliding door and the robot, or within the reach of the robot. You all understand that? floor mats, flight curtains, are you okay there? Y'all understand those? Yes or no? Huh? Proximity sensors, let's see. And like I said, I just wanted to go over, we're not safeguarding. This is some of the stuff that y'all were supposed to look at, that safety video, and also a safety lecture, which I went over this slide. But the only reason I'm doing this is, of course, y'all missed on the last test, where was most of the questions were missed on what? Safety, which should probably be your most important feature. You can look at every one of these robot manuals, and the first section is what? Safety. You can go out and buy a new TV, and when you get that manual that tells you how to install it, the first section is what? Safety. You can go out and buy a new electric toothbrush, which I did, and the first section of the manual is what? Safety. Now what that means is that if you get in there and you get hurt with that toothbrush, whose fault is it? It's yours. And that's why it keeps all the legal sections out of the way. You were supposed to send me an email. I think I got a couple. I know I got one from Lamar. Did I get one from y'all? I think. Get one from everybody else. Get one from you. Okay. I'm watching the safety video. That was one of your assignments. Those assignments count those assignments count as 15% of your grade. And the due dates are posted on the calendar. Right? Y'all understand that? I think right now, if we look at Blackboard with the month that we're in, and of course what happens is that this is on the calendar, so for the course, which you're supposed to be keeping up with, right? You understand? And that's on the syllabus. And if you don't do them, then they're worth 50 points apiece, and you lose 10 points every day those things are turned in late. And basically in this class we have assignment due every week for the first 5 weeks, and it's only an 8-week term. And then so we're here, so this last assignment was due right there. And this assignment was assignment 5. I would have to go and look and see what assignment 5 was, but I think one of them was make like safety rules and stuff like that. Then we have another assignment which has already went out. The college sent y'all out email to do the course survey. Did y'all get that? Huh? No, assignment 5. Let me look. Assignment 5. Hopefully it was. Yeah, it's up there. It's been posted, right? So assignment 5 was due last Friday. I don't know, what did you say it wasn't up there? It's always been up there. Then all these assignments, the only assignments that's not available, if you look right here, this one's not available yet. I'm going to take this off right now. We require you to have it done by the the third test. But the college is already sent it out, so you'd be more than welcome to go out and do it and get that out of the way. It's up to you. But this is the only one that's not available right here, that you can't see. So this is what you see right here. And of course, so all these assignments are up there. There's a safety research, which was assignment 4. This is online. Huh? No, I don't put it on the announcement. I put it on the calendar. the course calendars. I mean, you're supposed to be checking the course calendar, and these assignments have been up there since the very first day. What's that? Yeah, I put that up there because nobody had done it. What do you mean? Well, the only thing that shows up on that list is when I send out an announcement. Okay, but I didn't send out an announcement. I sent out an announcement for assignment 4 because nobody had done it. Right? You understand that? Okay. You're responsible for looking at the course calendar to see when these assignments are due, just like when we have tests and stuff like that. So that's why I posted them up there. That would be like me sending out. So I sent out that announcement, you're right, for assignment 4, but I didn't send it out for assignment 1 and you did it. I didn't send it out for assignment 2 and you did it. I didn't send it out for assignment 3 and I hope you did it. Right? You understand? It's just that nobody had sent me an email saying that they had watched that video. Huh? I know, but when I sent out the assignment, y'all did it after that. I mean, that's fine. But, so assignment 5 is the safety. So what I'm going to do is I'm going to go ahead and let y'all, so I'll move assignment 5 right there. Okay? Because right now, if y'all doing out there and did it, then, and so what that is the safety procedures, So y'all need to do that. The review for the test is up there, and we're going to have a test right here. Okay. So the only reason the only time I sent out an announcement which popped up there was when, because nobody had done it. I hadn't got any emails. The only email I had got was from Lamar, and once I sent it out, some of y'all went out there and did it. And nobody in the class nobody in this class has signed up for those text messages either. Oh, Patrick has. I'm sorry. Sorry, Patrick. You just did it though, didn't you?
Yeah, I did.
Yeah. So once y'all create y'all's program, the next lab we're going to deal with is playing around with some other features. So once we create a program, what's some of the things we might want to do with it? Huh? Well, that's creating. So we create a program or teach a program. So we're going to create the program. But once we got it created, what's some of the things we might want to do with that program? We might want to test it, yeah, of course, and y'all going to be doing that. Well, some of the things we've already had to do it on some of y'all's while I was over there. We might need to change it, right? We refer to that as edit. We've been teaching this class quite a few times, and when you go over there and look at the programs that's available on your Teach Pendant, if we didn't do something, then we would have probably 200 programs on there with all the ones that the students have ran during the term. So what's another thing we probably need to do? Yeah, we need to be able to read these things. What else along that line? Modify would be edit, so that would be. Huh? That's edit. This is edit. So anything you say add instructions, reteach a point, any of that would be edit the program. What we're talking about, the program in general, what we might want to do with the program in general. Oh yeah. We need to know how to save it, but what's nice about most of your robots, it saves automatically. So you don't have to tell it to save the program, it does it automatically for you, which is pretty neat. But if I was going to be working with like Microsoft Office and I wrote a document, then I would definitely want to save the program. But this is, for just about all these robots, this is automatic. Becomes a problem when we want to modify a program, and we've got a program that's running, but we want to change it. Now, what we like to do is we like to leave the program that's running alone, because when we get in there and we start doing this stuff, we might screw that program up, right? You understand? So what would we do? Yeah, what we do is we'd make a copy. So we need to know how to copy the program, right? You understand? So I can make a copy of it, then I can screw around with the copy, and if something happens and I crash the copy, I can always go back to the what? To the original. So along that line, what we might want to do, can't have two programs with the same name on in the same directory, so what would we need to do? Yeah, we need to have the ability to rename a program. Now, along with a copy, there's a term called backup. Y'all know what the difference between a copy and a backup? What is a backup? So in computers, when we make a backup, so we lost the batteries on the controller on the Motorman robot, and power failed before we got the new ones in, and we lost everything. We lost all the copies that was on that drive. We lost all the programs that was on that drive. We lost everything. We lost the operating system on that drive. Well, how did we get it back? Yeah, but where was the backup at? No, the black drive, yeah, it was in my office. So a backup is when you make a copy of something on a transportable medium that you never intend to use. When you make a backup, you don't want to use it, right? You understand. So it's a safety feature. That's all it is. And you don't leave backups in the computer itself. So a backup is copy of information on a transportable media, right? You understand, that you use in case of emergencies. We had a guy in here working. He said, "Well, we lose them all the time. We have to use our backups all the time." He needs to figure out what's going on because something's bad, right? You'll understand. I wrote a textbook on computer repair and had it on my computer, and my hard drive crashed, and everything was gone. But I was okay because I kept a backup. In fact, I had three at three different locations that I kept up. So, because that was back, that was almost 700 pages worth of documents and pictures. And what's scary is you lose your original, and then you pray your backup's okay. Well, I had it in three different spots. So we need to be able to save. We need to figure out how to copy. We need to figure out how to back up. We need to figure out how to rename. Backup is almost the same as a copy. All we do is just we don't point it to the mass storage device inside the controller. We point it to a USB device or most all these things are USB devices now. Not USB. Flash, what we call flash drives. What we need to do when we modify the program, somebody said that we need to be able to do what? Insert lines. We need to be able to delete lines. We need to be able to modify lines. We need to be able to copy lines. Now, modify would include changing speeds, changing round off, or either actually touching up the point. Right? You understand that? That would be inside of all that, or even changing the type move. Change move. Do what? We call it touch up. What would touch up be? That means you change the position of the point. You don't change the type move. You change the position of the point and touch it up. Of course, change speed. Change round off. Anything else? We need to be able. We said delete lines, modify lines. So all this is what we refer to as editing. So we edit programs. When we edit programs, we should be able to insert lines, delete lines, modify lines, copy lines, or instructions. This would probably be more correctly to say, instead of lines, say instructions. Anything else can y'all think about? So this is what we're going to do. So what you're going to do is you're going to create this program where you're going to go around the outside of that box. Then what you're going to do is you're going to do what? You're going to copy that program. You're going to rename that program. You're going to delete your copy, just to get you familiar with that. Then what you're going to do is you're going to touch up the program. You're going to edit your program. You're going to reteach points. You're going to insert points and do other things in there that's going to allow you to play around with those programs. Are we okay? Any questions? Okay, guys, let's go to lab. And y'all gonna try to get that assignment 5 done right before tomorrow. I think the thing says before midnight Friday.